Good day, viewers all over the world. Uh, Today is another edition of my STEM class. We are looking at chemistry as a subject, and today is a continuation of what we have started in previous time. The 6 classified equations that needed to balance chemistry. Don't forget, balancing chemical equation is the backbone of chemistry, because what happens in chemistry is that substances come together to form another substance. So reactions take place in chemistry. So I've been able to identify 6 equations that you must balance. You must know how to balance as a student of chemistry, cutting across SS1, SS2, SS3, advanced level down to university. The one that I'll be doing today, with balancing, has to do with balancing ionic equation. Balancing ionic equation. Balancing ionic equation. Okay? When compounds are in aqueous form, ions are being generated. How do you handle such equations? Such that the law of conservation of mass that I have been emphasizing is being obeyed. Please take note of that. You balance chemical equation to ensure that there's an adherence to the law of conservation of mass. Otherwise, whatever that you are doing is rubbish. You are creating an imbalance. Today, we shall be looking at short equation in acidic medium. Acidic medium. At another time, we'll be looking at alkaline medium. How do you balance ionic equation or chemical equation in acidic medium? Don't forget that acid is associated with hydrogen ion, H+. Don't forget that. So that means you are going to see how this is being enforced in balancing an ionic equation. Now, just like in my previous edition on this series, you just got to know the techniques to adopt and to apply in balancing chemical equation. Otherwise, I tell you, you can spend hours trying to balance what you're supposed to balance in less than 1 or 2 minutes. And those are the things, by the grace of God, with my over 2 decades teaching experiences, I've been able to come up with techniques, strategies that can make learning and assimilation and understanding easy for students. And you're going to see that at work here also. It's about techniques, it's about experience. So now we're going to look at an example of short cases of an ionic equation that needed to be balanced. In this case, we are emphasizing on acidic medium. What are the attributes, what are the features that is associated with balancing an ionic equation in an acidic medium? You will see that in this first example. Now I have chromate ion, Cr2O7 chromate ion, giving resulting into chromium ion, C3+. We want to balance this, and this reaction is taking place in an acidic medium. Don't forget, in an acidic medium. How to balance this? Again, there are steps that you need to follow, different from the step I gave you under inorganic equation, where you balance hydrogen first, followed by oxygen, then another atom. Different from the way you balance organic equation, where you double the carbon content of the hydrocarbon before you balance the carbon existing in another place, and then you now balance the hydrogen atom, and then you now come back to balance the oxygen atom. We have done that in previous series. I encourage you to always subscribe and view my video. Again, please, this is a free channel to make knowledge and understanding easy for students all over the world. In due course, we will create a platform where you can support this production in kind and cash. We need money with funds. We will be able to have more and more of this. Don't forget, I am a STEM tutor. It means I've gained over almost 3 decades experience in classroom communication of mathematics, further maths, physics, chemistry, biology, agric science, engineering courses, especially civil engineering and agricultural engineering, which is where what I study particularly. I have skill and experiences to showcase, so we need your support. Not now. What I'm doing currently now is to give free lectures, but at a point in time, it cannot continue to be free. We will need your donation, we will need your support, we will need you to subscribe, and we will need you to follow us morally. Thank you very much. Now let's come back to this. Now this is an ionic equation. To balance this ionic equation in an acidic medium, it has steps that you need to follow. The first step is that, listen to this, you will balance oxygen atom. Balance oxygen atom. Look at this. By adding equivalent number of water molecules to the side that is deficient of oxygen. Look at this side. This side, the reactant side has oxygen, 7 oxygen atom. The product side does not even have any oxygen atom. But because it is in an acidic medium, you will balance oxygen atom here by adding equivalent numbers of water molecules in moles. So it means that since I have 7 oxygen atom here at the reactant side, I will balance by adding 7 moles of water at the product side, so that 7 oxygen will appear there. So I have Cr2O7 2 minus, giving me, this one is there, Cr3 plus. Then I need to add 7 molecules of water, 7 moles of water, so that oxygen will be balanced. You see, here we have 1. Don't forget that it's 1. We don't normally put that 1 there, but it's 1 that is there. If there is nothing there at the subscript, it's 1. So 7 times 1, 7. Here we have 7. That's the first step. Step 2, you now go ahead to balance hydrogen atom, because by adding water molecules at this side, you have created an hydrogen atom, and which is not at the reactant side. How do you balance hydrogen atom? Because it is in an acidic medium, you balance hydrogen atom by adding equivalent number of hydrogen ion. Look at hydrogen ion. Equivalent number of hydrogen ions. Now here we have 2 times 7 or 7 times 2, that is 14 hydrogen atom. It means that I have to balance this side by introducing 14 ions. So that means I'm going to have Cr2O7 2 minus plus 14 hydrogen ion, giving me what do you call it now? That is Cr3 plus, there plus 7 molecules of water that is here. Now, with this now, I will now look at which other element. Chromium. Chromium at the reactant side is 2. Can you see it? 2. Chromium here is what? 1. So I will now balance any other atom apart from hydrogen and oxygen, which we have taken care of. So here now, to balance this, just put 2. Don't forget stoichiometric coefficient. You put it beside that species or substance or ion. So chromium is now 2. That is the third step. The fourth step is that for an equation to obey the law of conservation of mass ionically, the charges content, the charges must be balanced. The charges must be balanced. And how do you balance the charges? You introduce electron, equivalent number of electron to wherever side is deficient. You introduce electron to balance the charges. Now let's look at what happened at this side. Let's look at this critically. This side and this side. Look at it. Let's look at the charges carefully. Here we have plus 2. Can you see that? Plus 2. 14 times 1. Here, this one means 1. There's a 1 here that is invisible. So 14, that is plus 14. So that means the charges here is 16 altogether. Plus 16. Now let's come to this side. Let's come to this side. Are you here? How many charges here? 2 times plus 3, that is plus 6. These 2 multiply this. 2 times plus 3, that is plus 6. This one does not carry charge. It's not ionized, that is 0. No charge, you can't see any charge. The charges can either be plus or negative. No charges here, that is 0. So this is what? Plus 6. It means that in terms of charges, the equation is not balanced, and meaning that the law of conservation of mass is not obeyed. So you balance charges by introducing electron. Don't forget that electron is negatively charged. It's a negative charge. So it means that we need to reduce the charges of this by adding electron to the reactant side. How many electrons do we introduce to this, which is minus, that it will balance this 6? That's 10. Because plus 6 minus 10 will give us 6, which is 6 here, plus 6, which is also plus 6. So that means I'm going to introduce that here. I'm going to introduce plus 10 electrons here to balance this equation. Can you see that? Plus 10 electrons. So that we have plus 2 plus 14 minus 10. You see now, I told you this is 10 times minus an invisible one here. That's minus 10, giving you plus 6. And here is also plus 6. That's example 1. Thank you for that. Example 2. Let's take another example to buttress this properly. Still in an acidic medium, okay? Let's look at manganese ion, MnO4. Then we have this Mn2+. In an acidic medium, this side is the deficient of oxygen. We balance this side by doing what? By introducing equivalent number of water molecules. 4 moles of water, because there are 4 oxygen here. So it will be Mn2+ plus 4 molecules of water. So you can see the oxygen here now is 4. Oxygen here is 4. Now, by introducing water molecule at the deficient site of oxygen, you have created an imbalance of hydrogen. 8 hydrogen atom. 8 hydrogen atom. Don't forget that we balance hydrogen atom by introducing hydrogen ion at the deficient site now. So that means we need to introduce 8. So we have MnO4 minus plus 8 hydrogen ion. Because this symbolizes acidity, okay? Giving us Mn2+ plus 4 molecules of water. Then the other element we need to look at is our manganese, Mn. Manganese is one atom here, 1 atom here, so it's balanced. Now it remains the charges. The charges at the reactant side and at the product side, because it must be balanced. Otherwise, the law of conservation of mass is disobeyed. So here now, let's look at the reactant side, the charges. Let's look at the product side, the charges. Here we have no stoichiometric coefficient here, meaning 1 is here. 1 times minus 1. Here, plus 8 times plus 1, that is plus 8. Minus 1 plus 8, you agree with me that will give you plus 7. At this side, the stoichiometric coefficient is 1. 1 times plus 2, that's plus 2. This one does not have any charge. You can't see any charge. It doesn't have any charge because it's water molecule. That's 0 plus 0. So this one gives us plus 2. So we need to reduce the charge content at the reactant side by introducing electron. How many electrons do we introduce? to plus 7, that will give us plus 2, that is 5. Because 5 times minus 1 is minus 5. So if you introduce 5 electrons here, then it will balance. So that means this equation now will turn to plus 5 electrons. Don't forget to put this, giving you this, giving you this. So technically now if you look at it, the equation is balanced, not only atomically but in terms of charges. Now, as a follow-up to this, let us see how examiner may want to test you in an exam concerning balancing ionic equation in acidic medium. Now, I'm going to look at come up with 2 examples. The first example I'll be coming up with is this. Or before then, let's look at this. Another one, number 3. Let's try to balance this in an acidic medium. MnO4 minus manganese ion plus ion 2 plus giving us this Mn2 plus, okay, then ion 3 plus. Now if you look at this, the same rules in an acidic medium, not in an alkaline medium, because it's a different ball game. Today we are addressing acidic medium balancing of ionic equation. If you look at this, oxygen 4 atom here, no oxygen here. So you balance oxygen atom by introducing water, equivalent moles of water. So 4 oxygen here, so I need to introduce 4 moles of water. So that means this will be MnO4 minus plus F2 plus, giving us this Mn2 plus ion 3 plus, then plus 4 molecules of water. Water is 4 here now. Now, by doing this, hydrogen has come up here and it has been deficient here. So we need to balance hydrogen atom by introducing hydrogen ion, because that symbolizes acidity. Don't forget that. So how many hydrogen? 4 times 2, 8. So it means I need to introduce 8 hydrogen ion here. So I'm going to have MnO4 minus plus this one. Sorry, let me put the ion. Sorry, it is ion. Sorry, ion is Fe. Fe2 plus. Okay, plus 8 hydrogen ion, giving me Mn2 plus ion 3 plus 4 molecules of water, 4 moles of water. Now let's look at manganese elements. We have 2, 1 here, we have 1 here, it's balanced. Ion elements, 1 ion here, 1 ion here. Now it now remains the charges now, because it must be balanced in terms of charge at both sides. That's because without that the equation is not balanced. So that is the last stage. Now let's see it. The stoichiometric coefficient here is 1. 1 times minus 1. Here is also 1. 1 times plus 2, that is plus 2. Here is plus 8. Plus 8 times plus 1. Don't forget there's a 1 here before this plus. That's plus 8. So minus 1 plus 2, that's plus 1. Plus 1 plus D, that's 9. Plus 9. Now let's see whether it's balanced here. Here we have 1. 1 times plus 2, plus 2. We have 1 here also. 1 times plus 3, plus 3. This one is a molecule, so that's 0. So here we have plus 5, right? Plus 5. So it's not balanced in terms of charge. So we need to reduce this one by introducing electron. How many electrons do we add to this? How many negative value do we add to plus 9? That will give us plus 5. That is 4. So that means this equation to be balanced. We remove this arrow. You put plus 4 electron. Then you now put the arrow back. Then the equation is balanced. Now, let's now look at this type of question coming up maybe in Olympiad, JAM, university examination, or doing one thing or the other that has to do with balancing equation in ionic medium. Look at this. Let's say you are given this. Find what Y represents. Look at this. Represent in the chemical equation. Now look at the equation. You are given NO4 minus, okay, plus Y plus 5 of this, 5 AN plus, okay, giving you N2 plus 5. Oh, this one is 2 plus, please take note, then plus 5, 2 plus, 3 plus, sorry, thank you, then plus 14 molecules of water. Now, you are given the following option. Option A, 5 hydrogen. Option B, 4 hydrogen. Option C, 10 hydrogen ion. Option D, 8 hydrogen ion. Now, this is a practical question that you can come across in an exam, especially in form of objective. This can be a typical UTME question, SSC question, even question for you in tertiary, polytechnics, university, or colleges of education. It's still the same principle, the same concept. You can decide to remove this Y, remove this 5, this stoichiometric coefficient, remove this 5 for this ion 3, and remove this water completely, and balance the equation based on the 5 steps I gave you earlier on that we used to balance those 2 or 3 examples. That's one method. Remove this because you don't know what it is. Remove anywhere there is stoichiometric coefficient, remove them. Then remove water completely and balance. When you do that, what this Y represents will come out clearly. That's one method. Another method is that, don't forget that this is in an acidic medium. When you see water at this side and oxygen at this side, it means it reflects acidic medium. Take note of that. If you see water at this side, because in alkaline medium, you may see water at this side of oxygen. But here it also already showed to you that, oh, this is an acidic medium, because you are seeing water molecule at the product side. Get that insight right. Again, you look at this. The first step in balancing an ionic equation in an acidic medium is to balance the oxygen atom. The oxygen atom. Sorry, I think this is 4, not 14. The oxygen atom. Take note of that. That is 4, not 14. Okay? Now, let's see. Oxygen is balanced. 4 oxygen atom here. 4 oxygen what? Atom here. Okay? Oxygen is balanced. And you know the second step is for you to balance hydrogen atom by introducing hydrogen what? Ion. So this Y, that hydrogen ion is missing, so it's likely to be this. Alright? So how many hydrogen do we have here now? This is 4 times 2, 8 hydrogen atoms. That means we need 8 hydrogen ion here. 8 hydrogen ion. And I can tell you that the answer is this. If you want to cross-check, you check by looking at the charges, if the charges is balanced. Here, 1 times -1, -1. 8 times +1, +8. 5 times +2, +10. That gives us what? -1 +8, that is +7. That is 17, right? 7 + 10. Now let's see this side. Okay? This side now. This is 1 is there. 1 times this, that's +2. 5 times +3, that's +15. Then this one is a water molecule, no charge, that is +0. So this gives us what? 17. So you can see that it is balanced in terms of charge at both the reactant side and product side, which confirms that this answer is the correct answer. Look at it very well, please. Very interesting and simple question. No ambiguity, just apply the rules. Then finally, look at this. This seems more complex. This one will be more useful to students in the tertiary institution. It's a bit more technical. Look at that. Let me put it down. What is the value of n in, look at it, in this substance, potassium ion cyanide, aqueous. Aqueous means in solution form, giving us a reversible reaction of potassium ion, n moles of potassium ion, aqueous, and ion cyanide ion plus FeCN in bracket 6 here, everything in bracket here again 4, then 4 minus. It's reversible, and the reversible reaction, that's the symbol. That means this reaction can go both sides, okay? Now, look at this. If you look at this, there is no hydrogen, there is no oxygen. So that means they expected you to balance this in terms of, what do you call it? In terms of ion, in terms of charge they carry. They gave us option here. Let me give you the option. A is 0, B is 6, C is minus 4, G is 4, then E is 1. We need to find what this N stands for. How many moles of potassium ion is in this reaction? Now, since there is no hydrogen and there is no oxygen, you just balance in terms of what? Charges. And the total charge here must be equal to the total charge at the product side. Must be equal to that of the reactant side. If you look at the reactant side, there is no ion. It's a solution that is not ionized, no charge. Okay? So that means the total charge here is 0. It must be equal to the total charges here. Now here, let's start from this. N times plus 1, that's plus N. Then here we have, what is the charge carrier of this? The charge carrier here is what? Minus what? Minus 4, okay? So minus 4. So we are looking for N. So this is 0 is equals to N minus 4. Carry this N to this side. That will be minus N is equals to minus 4. Minus cancel minus. Divide both sides by minus. So N is equals to what? 4. Very simple. But I tell you, it may look simple because I've just taught you. If you are not familiar with this, you will even be confused. But the concept is that check for hydrogen atom, no hydrogen atom, check for oxygen atom, no oxygen atom, then you consider the charges. Okay? You balance it in terms of charges in the reactant side being equal to the charges in the product side, and you generate this equation here. I believe you have this has added to your knowledge. Please subscribe to this YouTube STEM TSP STEM resource. We have made up our mind to continue to make knowledge available and easy, especially in the area of STEM. Keep on watching my
down the river we drunk and all of our thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over we down. We're getting on fire.